Hi, welcome back. What we've done here is to take that external view of the heart and we've sliced the heart from top to bottom so that you can see on a diagram what is happening inside that heart. Well, the first thing that you would notice is that your heart is divided into 4 quarters or 4 chambers. There's an upper chamber called the right atrium. There's an upper chamber called the left atrium and lower chambers called ventricles, a right ventricle and a left ventricle. And so the heart works on the basis of blood in each chamber gets pumped to the next chamber, gets pumped out of the heart to pulmonary circulation, gets pumped back into the heart at the atrium, down into the ventricle and out to the rest of the body. And in this way, we never get our oxygenated and deoxygenated blood mixing. So let's look and see how that circulation takes place through the heart. Well, the blood comes to the heart via these 2 veins called the inferior vena cava, which enters in there, and the superior vena cava, which enters there, into the right atrium. The superior vena cava is bringing the blood from your arms and your head, inferior vena cava from your legs and your abdomen. And the blood is then pumped into the right atrium. So I'm going to call that 1. That's the first place that the deoxygenated blood arrives in. The right atrium pumps that blood through into the right ventricle. That is the second place that the blood flows into. And both 1 and 2 are deoxygenated blood. The blood then gets pumped by the ventricle, which you'll see has a thicker wall than the atrium. So it's a stronger muscle. It pumps that deoxygenated blood out of the heart to pulmonary circulation via the pulmonary arteries to your left and to your right lung. We discussed last week how pulmonary circulation exchanges carbon dioxide for oxygen, and reoxygenated blood comes back to the heart via the pulmonary veins, oxygenated blood from the left and the right pulmonary veins into the left atrium. That is the third place or the third chamber that the blood flows into. And this time the blood is oxygenated. The left atrium then contracts, pumps the blood into the left ventricle. And that is the 4th chamber of the heart that receives oxygenated blood. You can see that the left ventricle wall is even thicker than the right ventricle wall. This wall is very muscular and it pumps the blood with enormous pressure out of the heart again via the aorta, and that is now going to systemic circulation. And so that is how the blood flows within the heart. Because there's this septum or wall between the left and the right sides of the heart, we never get deoxygenated blood mixing with oxygenated blood. Never do the 2 forms of the blood, or the deoxygenated and oxygenated blood, never get a chance to combine. They're kept separate. When your blood is flowing in the heart, it doesn't just flow easily through the heart, it has to be pumped. The cardiac muscle has to contract in order to push that amount of blood that's in the little chamber out of the chamber. We call the contraction stage systole, and we call the relaxation stage, when the chambers open up, diastole. The diastole means that the chambers open. The systole is the contracting or contraction phase of the heart. And so we can see when the vessels receive their blood after systole, the heart receives its blood after diastole. And that accounts for that very characteristic double sound that you hear when you listen to someone's heartbeat, that lub-dub, lub-dub. The first sound that you hear is systole. The second sound that you hear is diastole. And that is what we call the cardiac cycle. You need to be able to be very sure that you can trace the path or the route that blood takes into the heart, out to pulmonary circulation, back into the heart, and out to systemic circulation. You also need to be able to describe what happens during systole and diastole. And that brings us to the end of looking at the heart today and how the heart functions. After the break, we're going to be looking at an aspect of homeostasis called temperature regulation. So I'll see you after the break.